Okay, this is section 4.5, part 1. And this section is going to be graphing y equals sine x and y equals cosine x. And then they are going to do things to those graphs, either stretch them or make them shorter, make them longer. They might translate them. So the first thing we're going to talk about is how we come up with the graphs of sine and cosine. So the first thing I put on here is this really tiny picture of the unit circle, but you guys have that, so you can look at those numbers if you need to from your unit circle. And then I just chose some angles. I chose 30, 90, 120, 180, 270, and 360. And I put the values of sine and cosine of those angles on this table. So we know that the sine of 0 is 0 because that's my y value. The cosine of 0 is 1. Sine of 30 degrees is 1/2, or the cosine of 30 is square root of 3 of 2. And then next to them, I wrote down what each angle would be in radians. So what we're going to do to graph is we're going to, if we look at y equals sine x first, we can use the points on our unit circle to graph sine and cosine x. The angles will be on the x-axis, and our exact trig value will be our y-axis. So if we graph y equals sine x, so first of all, and it may be kind of hard to tell, but this graph goes, we're going to do the positive side first. This goes from 0 to 2 pi. Okay, and that kind of makes sense because our unit circle goes from 0 to 2 pi. And then, so this is pi over 4. Let's see, it is really hard to see. Pi over 2, 3 pi over 4, pi. And you see my values on there. So, I'm going to graph y equals sine x first. The easiest points to graph for sine x, see where the sine of 0 is 0. So if I start at 0 degrees, I know my y value is 0. Okay, and then I'm going to go over here to 180 degrees. See at pi, sine of pi is also 0. So pi is right here. So that's 0. And then 2 pi is also 0. So when I'm graphing sine x, those are the very first points that I always graph because I know 0, pi, and 2 pi are all 0. And then the one I do next are my easy points. Okay, I know that the sine of pi over 2, okay, the sine of 90 is 1. So here's pi over 2 right here. It's 1. And then see this one, sine of 270. So, or 3 pi over 2, here's 3 pi over 2. It's negative 1. Okay? And now I can connect these points if I want with this little sine curve. Or when I connect these, we want to do it with a smooth curve, not line segments. Okay, or if we wanted to fill in some more, I know that the sine of pi over 6 is 1/2, but they didn't give me pi over 6, they gave me pi over 4. So pi over 6 it's going to be 1/2. And I could plot these other points, square root of 3 over 2 for 2 pi over 3, but that's just a weird number. So really, these are the points that I use to graph the entire thing. And it looks something like this, if I can get my marker to cooperate. Okay, that's from 0 to 2 pi. That's what the sine graph looks like. So I used, this point, this point, this point. I just use basically those 5 major points all the time. And I just made this chart so you could tell where I got those points from. All right? So now, what if I wanted to do the negative part? Well, I know, I'm going to do my 5 major points again. I know that the sine of negative pi, so negative pi, my unit circle would be right here. So the sine of negative pi is 0. The sine of negative 2 pi is 0. The sine of negative pi over 2, so negative pi over 2 is this point right here. The sine of that is negative 1. So I know negative pi over 2 is negative 1. And then let's do one more point, which is 3 pi over 2. So negative 3 pi over 2, my sine value is 1. So you see how if I continue this curve on, so there is my graph of sine x from negative 2 pi to positive 2 pi. Okay? Now let's talk about the domain and range of this graph. domain of our x values. Are there any x values? And I could continue this graph on however long I wanted. So my domain would be, and we can write it however we want, negative infinity to infinity or all reals. My range are my y values. How far up and down did this graph go? My lowest point was -1 and my highest point was +1. So it's between -1 and 1. And how I would write that, -1 is less than y because it's my range, my y values, is less than or equal to 1. And then they're going to introduce what they call a period. A period of a graph is how far on the graph do you have to go before your graph will start repeating itself. Okay, well, we can think of it as our unit circle. How far around do I have to go on my unit circle before the values of my unit circle start repeating themselves over and over? Well, I would have to go 2 pi. Okay, or I can look at this. If I start here at 0 and go to 2 pi, and if I kept going, this curve would keep repeating itself over and over. You see from -2 pi to 0, it's the exact same graph as 0 to 2 pi. Okay, so my period for sine is 2 pi. All right. Now, they're also going to introduce another vocabulary word. It's called the amplitude of your graph. The amplitude of this graph would be how far up in a positive direction does it go. Okay, so my amplitude is 1. The highest it went was 1 unit. Okay, amplitude will always be a positive number. All right, and it's just easy to see how far up did this go. 1, it went down a -1, but amplitude is always positive. Okay, so this will be a graph that you will need to memorize. You need to automatically and quickly be able to graph y equals sine x, and knowing I would basically know these 5 points. Okay, so let's look at y equals cosine x. Okay, so let's do the graph of y equals cosine x. Again, I have your unit circle, and I just picked some values of those from that unit circle. So let me show you the points that I usually use in order to graph y equals cosine x. I know at 0, cosine is 1, so I always graph that one. I also know at pi over 2, cosine is 0. And then I know at pi, cosine is -1. And then at 3 pi over 2, cosine is 0. And then at 2 pi, it's back up to 1. So I use these points, and you can graph some of the other ones, but they're going to be fractions or whatever, like cosine of pi over 4, square root of 2 over 2, square root of 2 over 2 is some decimal. Okay, but it would be around this point. But here's how I would graph this. Remember, these are nice smooth curves. They are not line segments, so you need to draw them as a nice smooth curve. And then if I go backwards and do the opposite, let's do -pi. So -pi is right here. So cosine at -pi, let's see here, -pi cosine, that's going to be -1. Cosine of -2 pi, that's all the way around. I'm going to be up here. Let's see, -pi over 2. -pi over 2 is right here, and cosine is 0. And -3 pi over 2. -3 pi over 2 would be this point right here. -3 pi over 2 is 0. So you notice if I continue this curve on, looks something like this. Okay, so there is my cosine curve. All right, let's talk about the domain and period. Domain, again, would be all reals. Those are my x values, and I could continue this graph on and on. My range, how far up and how far down does this go? Well, again, my lowest point is -1. My highest point is +1. And my period, how far around do I have to go in order for my graph to completely repeat itself? Well, again, it's 2 pi. Okay, if I notice, if I just look at this graph from negative 2 pi to 0, that's one complete cycle of my cosine graph, and then it starts over from 0 to 2 pi, and then it just keeps going. So my period is 2 pi. Again, this is a graph you need to memorize. And if you notice, your cosine and sine graph look almost exactly the same. It's just your cosine graph is shifted over to the left a little bit. Okay? All right, so sometimes they're going to give you your sine and cosine graph, and they're going to want you to do something to it. Either change, oh, let's go back. What's the amplitude of this? Amplitude is how far up did I go from the x-axis? Well, the highest I ever went was 1. Okay? Now, sometimes they're going to want you to change something. They're either going to change your amplitude or they may change your period. So I gave you some guidelines for sketching graphs. And if you'll notice, it says to graph y equals a sine bx or a cosine bx. So sometimes they're going to give you a number in front of the sine, and sometimes they may give you a number before the x. Those two things are going to tell you two separate things, okay? So if you have a number in front of your x, it's going to change your period. Your period would be 2 pi divided by that b, or by that number in front of your x, okay? The a changes your amplitude. All right, so if you have a number in front of your sine or cosine, it changes the amplitude from 1 to whatever that number is. Okay, so let's go ahead and graph example 1. You don't even really need to follow these 5 steps for number 1 because it's pretty easy. So first of all, you need to write down the amplitude and period for each of these graphs. My amplitude for 2 sine x. Okay, if I ever have a number in front of the sine or cosine that's being multiplied by that, that is my new amplitude. So my amplitude is now 2. So what that means now, before it was 1, so instead of going up 1 unit, I'm just going to go up 2. My period is always 2 pi divided by b, and b is the number in front of the x. Well, I don't have one, so that's going to stay as 2 pi. So now we're going to graph 2 sine x. So for sine x, I always start at 0 because I know sine of 0 is 0. I do sine of pi because it's 0, and I do sine of 2 pi because it's 0. Then I go to pi over 2 because I know that pi over 2, sine is 1. But this time, instead of going up 1, I'm going to go up 2 because my amplitude told me to do that. Now at 3 pi over 2, which is where I always put my other point, it's usually negative 1. But instead of going down to negative 1, my amplitude tells me I'm going to go down to 2. So anytime I would normally go up 1 or down 1, I would go up 2 and down 2. All right. Now, usually in your book, it's going to tell you how far they want you to graph. Sometimes they'll say graph from 0 to 2 pi. Sometimes they'll say negative 2 pi to positive 2 pi. Okay, so if it just said graph from 0 to 2 pi, or if it said graph 1 period, then this is all I would have to graph. But if it said graph 2 periods, or graph from negative 2 pi to 2 pi, I would have to go ahead and continue this on. So this is my answer if I just had to graph 1 period, or from 0 to 2 pi. Let's go ahead and continue it on in case I needed to graph from negative 2 pi to 2 pi. So I know at negative pi at 0, at negative 2 pi at 0, at negative pi over 2, it would normally be down here at negative 1, but this time it's going to be negative 2. And then at 3 pi over 2 is my other point. So here's what it would look like. Whoa, it's kind of hard for me to connect them. There is my graph of 2 sine x over 2 periods. Okay, so let's look at example 2. All right, this time I'm supposed to graph y equals negative 2 cosine x. So let's list our amplitude first. Even though this is a negative 2, remember amplitude is always positive. So my amplitude is still 2. My period is always 2 pi divided by b, but I don't have a number in front of my x, which is my b number, so it's still just going to be 2 pi. All right, so for cosine, I always start here at 0 because I know cosine, I start at 1 because cosine of 0 is 1. Now here's what this negative 2 is going to do. First of all, I know instead of up 1, I'm going to go up 2. And this negative means I'm going to flip it. Okay, anytime I'd normally go up, I'm going to go down. Anytime I'd normally go down, I'm going to go up. So at 0, so the cosine of 0 is 1. So at 0, I normally go up 1. But now I'm going to go up 2, and since it's negative, that means I flip it around and I'm going to go negative 2. Okay? Let's find our other easy point. The cosine of pi over 2 we know is 0. So at 0, it's still just 0. Our other easy point was cosine of pi. Okay? Cosine of pi is normally negative 1. So normally at pi, I would go down to negative 1. But since my amplitude is 2, okay, I would normally go down 2. But since it's flipped, do you see I'm going to go here? Cosine of 3 pi over 2 is my other easy point. Cosine of 3 pi over 2 is 0. And then cosine of 2 pi is my other point. So normally 2 pi would be 1. But remember, we're flipping everything, and my amplitude is 2. So here is my graph of negative 2 cosine x. And we could continue this on if we needed 2 periods of it, or if it said go from negative 2 pi to 2 pi. Okay, we'll leave it like that. So that's 1 period from 0 to 2 pi. Okay, so let me see. We may break this up. Okay, we'll go ahead and do this. Example 3, graph y equals sine 2x. I included the guidelines for you. First of all, my amplitude. I don't have a number in front of my sine or cosine, so I know my amplitude is just 1. My period is 2 pi divided by b, and this time I do have a b. It's 2. So my period is 2 pi divided by 2, which simplifies down to pi. Now here's what that means. That means now I have a complete graph of sine from 0 to pi. Okay? So from 0 to pi, I have my entire thing. All right, so here's how you're going to do this. And I may have, let me see here. All right, so here's what I do. Okay, we can read these, we can go through these if we want. But I know for sine, I have a starting point at 0 and an end point at 0, and my midpoint is 0. So now if I'm going from 0 to pi, the middle is pi over 2, and I know my midpoint is 0. Because if we look back at sine, see how my starting point was 0, my midpoint was 0, my end point was 0. All right? So that's what I just did. Starting point, midpoint, end point. Because now I'm going to end at pi. Now, right between 0 and my midpoint, so right between there, which is this point right here, I know I go up to 1. All right? So this point right here is 1. Right between this, my midpoint and my end point, which looks like it would be right here, I know I'm going to go to 2. I'm going to go down to negative 1. So if I connect these points, there's my graph of sine 2x. Now if I wanted to continue this, I could go from pi to 2 pi. Here's my midpoint. Here's my beginning point. Here's my end point. I can't really tell what that says, but my middle point, I know right in the middle of that, I'm going to go up to 1. I'm going to go down to 1. So do you see that if we graphed from 0 to 2 pi, now I have 2 complete periods. Okay? Or I have 2 complete graphs from 0 to 2 pi, when normally I would only have 1. Okay, now I'm going to show you how to label these points as we go along. Um, okay, let's save example 4 for the next video, and that way I can take more time in showing you how to label your points. So I may have to get rid of this graph since it's already labeled and just give you a blank graph so you know how to label your points and know what point goes where.